Assalamualaikum and good day. Welcome back to CMA 422 Structural Design. For today, we're going to learn a new chapter which is Reinforced Concrete Foundation Design. Foundation may be divided into two categories, which are deep foundation, which as you know, piling, that one under deep foundation, and we have a shallow foundation, which include the pad footing, strip footing, mat footing ataupun rough footing. In our syllabus, we're just going to cover on the design for pad footing.
What is pad footing ataupun pad foundation? Isolated pad bases are square or rectangular slabs provided under individual columns. Load yang akan ditransfer daripada individual column akan transfer pada pad foundation. They spread concentrated columns load safely to the ground and may be axially or eccentrically loaded. Perhaps kalau axially dia akan macam betul-betul dekat tengah-tengah ya. Tapi kalau eccentrically loaded meaning dia mungkin dekat loading dia tak betul-betul bukan dekat axis . Mass concrete can be used for lighter foundation if the underside of base lies inside the dispersing angle of 45 degrees. Otherwise, reinforced concrete pad is required. Okay, whether you can use a lighter foundation, contohnya pakai mass concrete saja ataupun teruskan saja pakai reinforced concrete pad foundation. For what we're going to learn about reinforced concrete pad footing lah, how to design it. The general procedure to be adopted for design of pad footing is as follows. What we need to calculate the plan area, meaning the size of the footing, using serviceability load. So sebelum ni you ada belajar ULS and SLS, which is ultimate limit state and serviceability limit state. Jadi sekarang masih kira ultimate load. So itu adalah to cater the ultimate limit state punya requirement. Okay, bila kita kira untuk serviceability load to cater SLS lah, which is the serviceability limit state. Determine the reinforcement areas required for bending using the ultimate load. You still need to calculate the ultimate load untuk dapatkan AS. And check for punching shear and transverse shear failures. So kita kena check juga failure yang lain, whether soon our footing will deteriorate because of this failure. So this one I can explain nanti, but just to give you some ideas lah. Okay, yang shaded area critical section for bending. So area yang ni yang kita akan kira untuk design for AS ataupun untuk design macam kita nak letak bar. And then we have here like vertical shear and punching shear. So ini adalah because of transverse shear. Vertical shear ni transverse shear yang akan cause the shear failure. Ini area yang kita akan kira. And punching shear, okay, this is the area that we're going to calculate. So kita akan kena kira area-area ni semua because of this area yang prone for punching shear and this area yang prone for transverse shear. We must know apa itu bearing capacity. Basically bila kita design ni is actually based on the bearing capacity ataupun capacity tanah yang tempat kita nak transfer the load daripada footing tu sendiri. So bearing capacity is the capacity of soil to support the load applied to the ground. So kita kena tahulah because later on daripada foundation tu, whatever that come to the foundation, the loading that being transferred to the foundation will be transferred to the ground. So we must know the bearing capacity of the ground. So safe bearing pressure is the maximum pressure which the soil can carry safely without risk of shear failure. It is equal to the net safe bearing capacity plus original overburden pressure. It is the bearing capacity after applying the factor of safety. So basically safe bearing capacity ni sebenarnya kita dah consider the factor of safety sebab bearing capacity yang here kita tak consider lagi dia punya factor of safety. Sebab itu adalah bearing capacity yang tanah tu boleh carry to the maximum. But bila kita design anything, we must consider putting some additional factor of safety so that kita tahu, kita allow some values plus minus to make sure that it is entirely safe. So that's why ada safe bearing pressure, this one, which also consider the factor of safety. And then we have the ultimate bearing pressure is the least gross pressure, which will cause shear failure of the supporting soil immediately below the footing. Gross pressure, which is pressure lah, yang akan cause shear failure, yang akan menyebabkan shear failure. Ultimate bearing pressure ni kita kira on the footing itself lah. So macam self bearing pressure ni meaning say very dekat ground tu. Okay, but ultimate bearing pressure ni bearing pressure yang paling tinggi yang menyebabkan soil to fail immediately below the footing. Maksudnya bila dah ada transfer load and such, so footing tu akan menyebabkan ground itu fail. So itu adalah ultimate bearing pressure. So a bearing capacity failure is defined as a foundation failure that occurs when the shear stress in the soil exceed the shear strength of the soil. Because of shear stress yang caused by whatever yang being transferred pada the soil tu melebihi shear strength of the soil. Maksudnya kekuatan soil tu sendiri. Bearing capacity failure can be grouped into 3 categories. As follows, we have general shear, local shear failure, and punching shear. So we're going to look at one by one. General shear, a continuous failure surface developed between the edges of footing and the ground surface. Jadi you ada footing kat sini kalau tengok gambar, and then you ada ground surface here. As the pressure is increased toward the QU, QU ni apa? Ultimate bearing pressure, yang this one. QU tu adalah ini, ultimate bearing pressure. Cause your failure of supporting soil immediate below the fail. Maksudnya dia dah nak fail lah tu, leaning towards the value yang dia akan fail QU, the state of plastic equilibrium is reached initially in the soil around the edges of the footing. So plastic equilibrium ni maksudnya soil mass ataupun portion of soil mass bawah tu dia dah deform. So ultimate shearing resistance ni akan mobilize. Dia nak resist the deformation tu. So ultimate shearing resistance ni dah bergerak dalam soil because of the particles kan, dia macam very small and then dia macam irregular Jadi bila dia irregular, dia ada friction between themselves Jadi bila dia dah nak deform, okay, jadi dia akan ada shear resistance yang akan try to resist the deformation of the soil. So itu adalah plastic equilibrium. Initially in the soil around the edges of footing, a wedge of compressed soil 1, so kalau tengok 1 dekat bawah ni, goes down then gradually spread downwards and outwards. Jadi dia akan spread downwards and outwards. Ultimately, the state of plastic equilibrium is fully developed throughout the soil above the failure surface. So akan jadi dekat sini lah, above the failure, dekat number 2. Okay, because of dia dah spread dia dah beralih the resistance tu. Heaving of the ground surface occurs on both sides of footing, although the final slip movement will occur only on the side accompanied by tilting of the footing. So heaving dekat sini maksudnya ground surface ni akan naik benjol. Dia akan ada movement kan. So you punya ground akan beralih dan ternaik ke atas lah. Okay, sebab you punya ni kan dah beralih. Tanah you kat sini, soil ni kan dia dah beralih. Tanah dekat sini akan ternaik lah. Ini akan termasuk ke dalam dan dia akan ternaik Akan terjadinya tilting, meaning that this foundation akan tilt. Mungkin akan sengit lah. Tapi sengitnya taklah teruk mana. Tapi it's affect your structure because benda ni yang support dekat bawah. So a slight tilting pun akan cause a lot of effect to your structure. This area are initially prevented from moving outwards by passive resistance on the soil wedges. Whatever here, dia akan resist. Okay, sebab ni nak naik ni. Ni dah beralih sini. And then soil ni, the one yang here, because of soil kan dia ada weight dia kan. So dia akan try to stop the movement of the soil Once this passive resistance is overcome, movement takes place and bulging of soil surface around the foundation occurs. So if this one fail, dia tak dapat passive resistance ni cannot resist the force that coming from all this direction whatsoever, akan ada bulging of the surface soil around the foundation occur. With general shear failure, collapse is sudden and is accompanied by tittling of foundation. So collapse, soil akan collapse, then foundation you akan terus tilt. This mode of failure is typical for soil of low compressibility. For example, dense or stiff soil, and the pressure settlement curve is of the general form shown in figure 8.1. Ini adalah low compressibility soil, bukannya macam high compressibility soil, contohnya macam clay, macam tanah gambut. But low compressibility soil meaning macam pasir. Pressure settlement curve ni, so if you see, ini adalah failure mode number 1. So the pressure dia lebih tinggi and akan ada settlement of soil. So if you look at around this area, so you nampak kat sini ada bulging because of whatever area number 3 ni dia dah cannot resist whatever the force that coming from above here. Ternaiklah bulging. And then the next one, we have a local shear failure. For local shear failure, the failure pattern developed is of the same form of general shear failure, but only the slip surface immediately below the foundation are well defined. Okay, kalau macam general shear failure tadi, slip surface tu maksudnya kan you tengok bulging besar dekat tepi tu kan. So itu adalah area yang affected lah, senang cerita. Kalau local shear failure, dia takkan effect sampai area-area dekat tepi tu. Shear failure is local and does not create a large zone of plastic failure which develop with general shear failure. Some heaving of the soil around the foundation may occur, but the actual slip surface do not penetrate the surface of soil and there is no tittling of the foundation. Jadi takkan sampai surface of soil, maksudnya atas lah, takkan sampai atas ni punya foundation kan. Dia akan drop jatuh ke bawah. Okay, takkan sampai di atas ni lah. Jadi bulging is not very nampak Some heaving of soil around the foundation may occur. Akan ada sikit lah heaving, macam upward movement of the ground. Mungkin akan ada sikit, but not as much as general shear failure. Dia tak penetrate sampai surface of the soil. So local shear failure is associated with soil with high compressibility. So because of this one, yang general shear failure dia low compressibility soil, meaning because of dia tak boleh nak compress, so tanah you bergerak because of the pressure that transferred by the foundation. But for local shear failure, it is for the high compressibility soil, meaning that pressure that come from the foundation yang press soil tu untuk settle, jadi untuk mendap, untuk compress, dia akan jadi compress macam tanah gambut. So this is what happen lah, just a slight bulging, tak banyak. Heaving of the ground is not too much okay, tak besar, and slip surface dia lebih well defined. Area ni dia being affected. Last kali, we have this punching shear occur when there is relatively high compression of the soil under the footing accompanied by shearing in the vertical direction around the edges of the footing. This is downward movement of foundation caused by the soil shear failure only occurring along the boundaries of the wedges of soil immediately below the foundation. There is a little bulging of surface of soil and no slip surface can be seen. There is no heaving of the ground surface away from the edges and no tilting of the footing. Relatively large settlement also characteristic of this mode. Okay, punching shear failure will also occur in soil low compressibility if the foundation is located at considerably depth. In general, the mode failure depends on compressibility and the depth of foundation is relative to its breadth. Kalau provide foundation kan, if you compare, katakan this is 3 meter by 3 meter, sama lah, katakan I letak 0.6 meter depth there. But if you compare here, this one is 2.5 meter and 2.5 meter, and this is 0.6 meter. So the one yang akan lebih mengalami this punching shear because of dia punya breadth dia kecil. Okay, bila kecil dia lebih senang termasuk ke dalam compact tu the one yang ada surface lebih besar, to resist surface lebih besar for friction, so that dia akan susah untuk termasuk, untuk being pushed downwards because of compression of the soil. Jadi normally punching shear ni lebih simple. If you see here, so this is what happened. Dia tak ada bulging, tak ada apa, but the foundation is being pushed downwards because of high compression. Ini kita dah masuk untuk parts yang kita nak design. So the area required is found the characteristic loads including the weight of the base. Berapa dia punya dimension of the footing punya size lah. 1.0 GK plus 1.0 KK plus 1.0 W. So here factor of safety dia only 1 lah. Ini adalah serviceability load. To get the area adalah sama dengan serviceability load. You dividekan dengan PB. Okay, what is PB? So PB adalah safe bearing pressure. So ini adalah bearing pressure yang selamat lah. Bearing pressure ada one yang dah ada factor of safety kat sini. So ini adalah bearing pressure yang you dah darabkan dengan factor of safety. But normally the value is given in the question, so you tak perlu nak susah-susah nak kira berapa dia punya factor of safety. Jadi kita just boleh je pakai value of the PB which is the safe bearing pressure. So ini adalah area you punya foundation ya. Kat sini kalau nampak LX, LY ni sebenarnya LX and LY. Jadi inilah dia area ni lah. Biasanya kalau kita design for foundation, pad footing, kita akan assume dia adalah square foundation. Kita just square root kan saja value of area ni. So kita akan dapat berapa satu side value of LX which is akan sama dengan value of LY lah. Kita kena kira juga ultimate design load as usual using the formula of 1.4 GK plus 1.6 QK. And we have this ultimate earth pressure punya formula. Okay, ultimate earth pressure ni, we need this value because kita dah dapatkan area tadi. Okay, and then we already calculate the design load. Maksudnya, berapa loading being transferred to the pad footing. And daripada loading tu, kita nak tahu untuk 1 meter square, berapa kilonewton yang akan being transferred to the ground lah. Daripada ultimate design load you tu, you bagikan saja dengan area dia, kita akan dapat ultimate earth pressure. When we get the ultimate earth pressure, we need to calculate the maximum design moment dekat YY. YY ni kat mana? Dekat sini. You ambil je PS, which is the ultimate earth pressure tadi. Sebelum ni, masa yang mula-mula tadi, I actually explain yang area mana yang you kena design bending reinforcement dia. Jadi area yang tu, inilah area dia. To get this area, so ini adalah dia punya formula. This area yang kena letak reinforcement lah. So LY darab dengan LX minus C divide by 2. Okay, macam mana dapat benda ni? C kat sini adalah column width, bukannya concrete cover This is C. Kita nak dapatkan area ni, LY, and then darab dengan, so LX, you ada LX. LX adalah dari sini sampai sini. Okay. Kita nak sampai sini je. So LX minus C. So LX, you buang area ni, you akan dapat panjang ini 2 je. And then you bagi 2, you dapatlah panjang ini saja. You dapatlah this value berapa panjang, berapa lebar dia kat sini. So that is LX minus C divided by 2. But the fact that kita nak moment, okay, ini bukan moment. Bila we want moment, as usual, kita kena darab daripada centroid pergi ke kat mana point yang kita nak cari tu. Okay, so mestilah daripada centroid of this shaded area. You know that panjang ni adalah LX minus C divided by 2. Tapi kalau you nak panjang ni saja, sebab you nak moment tu akan transfer to this point C, betul-betul dekat face of the column ni, you just divide kan value ni dengan 2. LX minus C divide by 2, you bagi lagi dengan 2. Because of kalau you bagi 2, maksudnya darab 1/2 lah kan. Jadilah LX minus C divide by 4. Kita akan dapat MY moment dy. For pad footing, kita tak cari WL square over 8, kita tak pakai tu, kita calculate MYY moment DYY. Formula masih sama, you calculate K, you calculate Z and S. And distribution of reinforcement, since you dah dapat S, kita kena design for reinforcement. So ini adalah typical cross section of bars yang kita belajar, tapi for foundation kita tak pakai the one yang spacing macam slab. slab saja yang pakai that kind of spacing punya table. Footing kita akan pakai, masih lagi pakai cross section of bars table. Kita dah dapat suitable, but we need to know the distribution of reinforcement. Where LC exceed 3C over 4 plus 9D over 4, 2/3 of required reinforcement should be concentrated within a zone from centerline of column to a distance 1.5D from the face of the column. Bila LC lebih daripada 3C over 4 plus 9D over 4, 2/3 daripada AS akan concentrated within a zone from the center line of the column. Center line of the column you kat sini. Column you tengah-tengah ni kan. To a distance 1.5D from the face of the column. Ke 1.5D kat sini. So, 2/3 akan concentrated dekat area ni. 2/3 AS. Dan 1/3 lagi akan concentrated dekat this area. 1/3 lagi akan duduk dekat sini. Otherwise, the reinforcement should be uniformly distributed over LC. LC ni apa? LC ni sebenarnya adalah LX divided by 2. You bagi je 2, you akan dapat LC. Kalau LC lebih besar daripada this value, 3C over 4 plus 9. Apa 3C over 4 ni? C ni column width, bukan concrete cover. And D ni adalah effective depth. Kalau value LC you bagi 2 ni, katakan 3,000 lah. 3,000 dah 3,000 bagi 2. You dapat 1,500. Lebih besar daripada value yang you kira dekat sini, you akan kena design dia macam ni. However, kalau LC is less than 3C over 4 plus 9D over 4, means that dia akan uniformly distributed. Tak ada yang concentrated you punya AS akan uniformly distributed kat semua area of the foundation you. Anchorage length adalah 37 times diameter. So, bila you dah choose suitable diameter, you akan kena kira anchorage length. So, what is anchorage length? You have this kind of foundation yang mungkin attached to the column. Anchorage ni maksudnya sambungan daripada column tu ke foundation. Nanti you akan ada banyak lah. Bar ni bukan 2 biji. Ni je dia ada keliling kolom tu ya. Ini adalah anchorage length which is 37 diameter. Panjang anchorage length ni lah. Cracking clause, the bar spacing, sebab kita kena juga kira spacing of bar, must not exceed 3D or 750 by the reinforcement percentage. You just kena ingat ini saja. Maksudnya sekarang bila you kira-kira, you must make sure that spacing yang you dapat tu mesti lebih kecil not exceed. Okay, sebab foundation ni kita worry dia lebih exceed daripada dia rapat sangat. Dia terlebih berjarak. 3D, D ni kat sini effective depth ataupun 750, which one less? Katakanlah kalau D you 400 darab 3 dah 1,200. So, kalau 1,200 lagi besar pada 750, you compare dengan 750. Tapi kalau D you less than that, contohnya 200. Okay, so 200 times 3 adalah 600. So, you akan compare dengan 600. 3D tu. Nominal cover. For foundation, you can ingat C ni ada 2. Satu column width, satu lagi concrete cover. Nominal cover ni, concrete cover masih lagi terpanggil C C mana yang you nak pakai. So, kita kena juga ada consideration for concrete cover. Kalau tak, macam mana pula you punya foundation tu akan exposed to the weather without the cover. Minimum cover should be 75 mm if directly against the earth. Kalau foundation you tak ada concrete blinding, directly against the earth, maksudnya directly, so you kena provide 75 mm. Tapi kalau ada concrete blinding, ada protection, you just provide 40 mm sahaja. We have done with the design for bending reinforcement. However, in our syllabus, we only learn about the theoretical part of punching shear and transfer shear. The calculation part will not be included inside this video because it is not in the syllabus. In our next class, we will learn more on how the calculation for this chapter. Okay, thank you so much everyone and have a nice day. Bye. Assalamualaikum.